Dear children, now let's discuss the first subdivision from the third problem of exercise 1.3. We are supposed to prove that 1 by root 2 is an irrational number. For proving this, we follow the usual technique, the method of contradiction. So suppose the contradiction that 1 by root 2 is rational. We have to prove it is irrational. We assume a contradiction against that is 1 by root 2 is rational. So as per our assumption, we could write 1 by root 2 as a by b. Let this be the simplest form of expression so that HCF of a comma b is equal to 1 and b not equal to 0. Since a 1 by root 2 is also non-zero, a is also not equal to 0. So this implies the reciprocal of a by b exists. Since both a and b are non-zero, the reciprocal of 1 by root 2, that is root 2, exists. So it is equal to b by a. This implies root 2 is rational. Which is a contradiction. A contradiction to the fact that root p is irrational, as root p is irrational if p is prime. So this implies 1 by root 2 is irrational. And now the second subdivision. We are supposed to prove 7 root 5 is irrational. We assume we prove by the same technique, the method of contradiction. That is, suppose 7 root 5 is rational. This implies 7 root 5 is equal to m, a rational number. Now divide both sides by 7. We get root 5 is equal to m by 7, which is again a rational. Since m is a rational number, m by 7 is also a rational number, which is a contradiction as 5 is a prime number. The contradiction as a contradiction to the fact that root p is irrational if P is prime. So this implies 7 root 5 is an irrational number. Similarly, let's prove the third subdivision. That is, we are asked to prove 6 plus root 2 is irrational, which is similar to problem number 2. Here again we assume the contradiction. We are asked to prove 6 plus root 2 is irrational. We assume the contradiction to the thing we need to prove, that is 6 plus root 2 is rational. Now subtracting 6 on both sides, we get root 2 is equal to m minus 6. M a rational number, 6 is also a rational number, therefore their difference m minus 6 should also be a rational number. But this is a contradiction to the fact that, as in the previous problem, 2 is a prime number and root p is irrational whenever p is prime. Therefore, we should have the assumption that 6 plus root 2 is rational is wrong, leads to a contradictory conclusion. So 6 plus root 2 is an irrational number. We will discuss the next section, introduce the next section and the problems related to that in the next lecture. Thank you.